in cutoff ratio. How this will looks like. Now, for that reason, we have to first consider process For process 3-4, you look that for process 3-4, you look that it is a adiabatic process. As it is adiabatic process, then what will be the relationship between T and V? That means T3 by T4 is nothing but P4 by V3 to the power gamma minus 1. That means, as we know, you see that V4 by V3 is RE, that means expansion ratio. It is RE to the power gamma minus 1. As it is RE, we can convert it in compression ratio and cutoff ratio. As we know, RP is equal to RE into RE. Then RE look like that. It is RK to the power gamma minus 1 by RC to the power gamma minus 1. Now, or we can write T4, sorry, yes. T4 must be T3 into RC to the power gamma minus 1 by RK to the power gamma minus 1, because T4 is in the lower side. Whenever it goes to that side, that means here the RK comes down lower side and RC go to the upper side. Now T4 for process what kind of process this is? Process 2-3. What kind of process this is? Go for what kind of process? It is a constant volume heat addition. As this is constant volume heat addition, constant pressure, sorry, pardon me, another time I do the mistake. This constant pressure heat addition. That means whatever we can write, it isn't adiabatic process. Then what the formula I use? I can use the formula, or not I can say, we can say we can use what the formula? This is PV is equal to RT. If this is thing, then what will be the formula? We can write P3 V3 by T3 is equal to P2 V2 by T2. Okay? Now we can say T3 by T2 is nothing but P3 V3 by P2 V2. Or we can say what? That P3 and P2, as it's a constant pressure process, P3 is equal to P2, or we can say T3 by T2 is nothing but V3 by V2. or we can say T2 is equal to T3 into 1 by V3 by V2, or we can say T2 is equal to T3 into 1 by RC, as we see that RC is equal to V3 by V2. Now we can say T2 is equal to T3 into 1 by RC. But now we comes to the another thing. This is what is process. Process 1 to 2. It is also we know that it's a reversible adiabatic process, and for that reason we can write T2 by T1 is equal to V1 by V2 to the power gamma minus 1, or we can write T1 is equal to T2 by Rk to the power gamma minus 1, or we can write T1 is equal to, as we know, T2 is equal to T3 by Rc into Rk to the power gamma minus 1, as T2 is equal to T3 by Rc. Now we have got all the T1, T2, T3, T4. Now we substitute all the value of this temperature in our formula of efficiency, that means diesel cycle. Diesel 1 minus T4 minus T1 by gamma into T3 minus T2. Now we can write 1 minus T4. What is the value of T4? We go to the, that is T3 into R to the power gamma by Rk to the power gamma minus 1. Yes, T3 Rc by Rk to the power gamma minus 1 minus T1, it is also T3 1 by Rc into Rk to the power gamma minus 1, and here it is gamma into T3 minus, what is the value of T2? It is T3 1 by Rc. This, now we try to simplify this thing. 1 minus, first we T3. Now if T3 is outside, then if we try to simplify, that is Rk to the power gamma minus 1 into Rc. Rc into Rk to the power gamma minus 1. For that, whatever we get, it is Rc to the power gamma minus 1 into Rc minus 1, and here gamma into T3 Rc minus 1. Now whatever we get, Then we can cross this T. Whatever we get that means one minus, that is RC to the power RK gamma minus 1 over RC gamma minus 1 plus 1 minus 1, and here it is RC minus 1 by RC into gamma. Then whatever we can write 1 minus 1 by gamma into RC to the power gamma minus 1 by RC into RK to the power gamma minus 1 into RC by RC minus 1. Now we can cross this RC into RC. Now we can write 1 minus 1 by gamma into 1 by RK to the power gamma minus 1 into RC to the power gamma minus 1 by RC minus 1. This is the derivation of efficiency of diesel cycle in terms of compression ratio and cutoff ratio. This is a very important derivation. Thank you for today's class.